Hello everybody, this is Solar Tiger with another solar power video. Today we're outside enjoying the nice sunny weather and I'm in the garden. And this is a video about my shed. Now I'm just going to show you that on the roof of my shed, on this side is a solar panel. That is a 50-watt solar panel. That used to be in my bedroom window. But now it's powering the shed, so that's the solar panel, and we go inside. You can see on the table out here that I have been working and using stuff, especially the soldering iron. So this is my shed, and I have redone the shed. So on the left hand side is a 50-watt solar panel that powers the shed. And on the right hand side, as I'm going to show you now, are the three 100-watt solar panels that are powering my bedroom, but we go inside the shed. Now I had to clear out in the shed to make space and to make it usable. So on this side there's mostly gardening equipment, and there's some shelving that has gardening and DIY type stuff on, and there's some stuff on the floor, but it's much tidier than it used to be. So on this side it has been totally tidied up and it's been reorganized. So this side is now my workshop. There's a workbench table, and there's a big tub of wood in the corner that I can use. On this side I have a workbench slash shelf, and you can see that it's been heavily used, and there's some stuff on the floor, but that's just there. So the thing is that in my shed I'm going to have some shelving up here, but I have installed a solar power system. So you can see, I'm just going to pause the music for a second. Right, so this is my solar power board. Up here is a solar charge controller. It's a 10 amp PWM solar charge controller. It was pretty much the cheapest one available on eBay, but I wanted one with an LCD display so I could check the voltage of the battery. Now this controller does not show any charging or discharging information. It is a cheap controller. So this is a 12/24 volt PWM charge controller. It's a 10 amp charge controller, and it has two USB ports on the front that I'm using to run stuff, but I'll come to that later. So this is the charge controller, and the float voltage at the moment is 14.4 volts. I have it set to 14.6, but the display doesn't show 14.6. It's because I have an AGM battery. If I show you the multimeter that's connected to the battery, it shows 14.67. So it is reaching the float voltage, it just doesn't show it. So this is a cheap solar charge controller. It has a menu. So I have set the float voltage to 14 volts. That is the reconnect voltage is 12.6 volts. That's when the low voltage cutout is operated. It will not reconnect until the battery gets to 12.6 volts. It is adjustable. I have set the low voltage cutout to 11.3 volts. It was the highest voltage that I could select, and it does have a timer facility, but I just have it on all the time, and I have switches to control my loads. And there's some features it says on the controller. So from the controller we go to a fuse board. Fuse board is important. You should have a fuse in every positive line. So I have a 4-way fuse box. Now, I did try to solder this wire, but I didn't really have a solder powerful enough. So from the fuse box we go to a switch panel where there's 4 circuits to match the 4 outputs of the fuse box, and they're labelled up here. So as you can see, I have a 12-volt outlet, I have shed lights. At the moment I only have 1 light, but I have a spare, and then I have my music system. That's one of the things I run on my system. So we have a cut-off switch for the battery, so if you have any problems I can just switch off and disconnect the battery. We have a 12-volt outlet. If I turn the switch on, you can see that my test light lights up. I can easily substitute the test light. Oops. I can substitute the test light. Oops. Sorry about that. I can substitute it for any 12-volt plug-in load. So that's how that works. Okay. The reason why the board came away when I pulled the test light out is because I have the board on a hinge. There's a hinge running down this side, and I haven't put a screw in this side, so that's why I can open it, or could open it when I push the battery box back so you can open it. I will be putting screws in here because I won't be opening it all that often. The system is connected to a battery. This is a 12-volt battery. It's a sealed AGM battery. As you can see here, it says valve regulated rechargeable battery, non-spillable, recombination battery. So this is a sealed battery, and under normal conditions any gases produced during charging are recombined inside the battery. It is valve regulated. In case of extreme overcharging it will vent out, but that's only if you really overcharge. Then there's some charging information. It says that the initial charging current must not exceed 6 amps. Well, that's not a problem because I only have a 50-watt solar panel, and if I remember rightly it can't put out more than 3 amps. I think it's about 2.7, 2.8 amps, so not a problem there. This box is normally turned around and covered, but I'm just showing you how it is. There is a fuse in line with the battery, very, very important. If there's a short circuit in the system somewhere, you'll blow the fuse instead of having a fire. Now this is a fuse. It's a 10 amp fuse to match the 10 amp charge controller. And I don't use a fuse holder, I simply use spade terminals. Spade terminals are a quick way of making a fuse holder. So the multimeter is showing 14.66 volts on the battery, so that's going okay. Now, as I said, the charge controller does not have any charging information, so to remedy that I have, in line with the solar panel feed, the plug and socket here acts as a disconnect if needed. So over here we have a watt meter, one of the eBay type watt meters, and it's saying now that I'm bringing in about 10 watts at 19.5 volts. That's 0.46 amps. Now I have been redoing my system. I had an accident I'll tell you about later, and I was using the soldering iron that you saw on the table out there connected to this battery, and I ran the battery down a little bit. So when I reconnected the solar panel, we had a peak charging current of 2.25 amps to bring the battery up. So that's one of these eBay watt meter things. There's a feed the cable goes round and through the hole in the wall to the 50-watt panel that you saw outside. Now, one of my loads is a music system. So this is the music system. This is just a module bought from eBay. Here is a similar one. This is a non-Bluetooth one, but this is the one that I was using before. It cost about £4, but I had an accident and it went bang. I'll tell you what happened. I had it in here and I put this outlet in for several reasons. One of them was to run my garden water pump, which draws 4 amps. And I plugged it in and I had a 5 amp fuse up here, and I had some issue with the water pump and it blew a 5 amp fuse. The fuse went bang. I don't know if I've still got the fuse around here somewhere. Yep, here it is. The fuse went boom, as you can see here. There's a dark bit in the middle of the fuse, that's where it blew the fuse, boom, it tripped out the overload protection on the charge controller, and then I heard another bang and some smoke, and my music module had let go. What I think happened was that the pump has a large motor, and the motor has windings in it, coil windings in it, and I think basically when it blew the fuse, the magnetic field in the coil collapsed and it induced a big voltage spike back into the system, and I think that's what blew my music module. So I won't be plugging that in anytime soon. So anyway, when I replaced the module, I bought one with the Bluetooth. So this one says Bluetooth speakers, and the old one just says, music speakers. So the Bluetooth one was £7 or £8, and the non-Bluetooth one was about £4. So I went with the Bluetooth one because it was convenient. So this is basically a music system. It has a tuner, and it has a memory card slot, a micro SD card slot, a USB socket, so you can play stuff from memory sticks, or you can use a card reader and use other memory cards. It also has a line-in jack, so you can connect it to devices that don't have any Bluetooth, so that might be handy. Now the music module only puts out a line level output, so it's connected to a small amplifier. If I can move this. Yeah, it's connected to a small amplifier. Just disconnect the solar panel. Okay. Right, now I'll just move the battery box. You can see that my board is on a hinge. I can hinge it out. So behind here is the back of the board. Now you can see up here, here's the back of the music module. There's a volume control. And then up here is a small audio amplifier board. It's a 2x3 watt audio amplifier board. It's USB powered. So you can see that there's a lead here, and that this white cable goes to the USB socket on the front. So that's how that goes. Right. And I have a volume control, so I can alter the volume. There's a volume control here, but I put one here as well, because when you change mode, the mode announcements are very loud, really loud. So I want to be able to turn the volume down when I change mode. That's why I did that. So the amplifier is connected to some speakers. So up here is a speaker. It's a Creative speaker out of a PC speaker set from a 2.1 speaker set. So I just used these speakers. There's one up there and there's one over here, and if I put the music back on a minute you can hear that it works fine. So that works very well. Just pause it again. So that's how that works. So this is my solar power system. I can plug my soldering iron in here, or fans, or any other 12 volt equipment I have. I was using this USB fan. I've turned it off because it makes noise and you wouldn't be able to hear me. So this is a quick overview of my system. The system is made using very cheap parts. There's nothing expensive in here. And the battery is a 20 amp hour battery. I bought this for about £14 second hand on eBay. The previous owner only had it for 2 or 3 months, so it was practically new. So it was a cheap battery. The charge controller was under £10. The fuse board was about maybe £4. So a couple of pounds in some switches. The audio amplifier board cost 99p. The music system module was about £7 or £8. It's just because it's the Bluetooth one. The outlet cost £2 or £3 as well. Wire was scrap. I got it from a building site many years ago. There's some car fuses. You can buy a whole box of these fuses for £1 or £2 from a discount shop. The stereo comes with a remote control to operate the stereo, and well, that is pretty much my solar powered shed. So this is Solar Tiger from the Solar Powered Shed. So I still have the system in the house with 300 watts panels connected to 3 batteries in the house and a 30 amp charge controller. But this is just a system for the shed. The shed does have lights. A light. It's a LED light bulb, 3 watt LED bulb from On Solar. It can run on any voltage between 10 and 30 volts, so it can be used on a 12 or 24 volt system. The brown wire is the aerial for the radio. So I used yellow and black wire in my system because I didn't have any red and black wire, and yellow and black wire is used in computers for all 12 volt wiring, so I'd simply just use that. So that is my system. So this is Solar Tiger saying thank you for watching. And now the system board is hinged, it's a lot easier to get to the back of it to fix things. So this is Solar Tiger saying thank you for watching, and if you like my video please subscribe and comment down below and watch my other videos. I have many other videos. So I will see you next time. So thank you for watching. Thank you.